all of these talks will be about the Queensland floods. First and foremost, I'd like to start with an acknowledgement. So the Queensland University of Technology acknowledges the Turrbal and the Yagara as the First Nations owners of the land where QUT now stands. We pay respects to the elders, laws, customs, and creation spirits, and we recognise that these lands have always been places of teaching, research, and learning. Okay. So, we all got to live through a natural disaster at the beginning of this year, which was the Queensland floods. And when something like that happens, we kind of realise the immense power that Mother Nature has over us, and there's a distinct feeling of powerlessness. And during the floods, there's a lot of watching and waiting. And if you're one of those people who are affected, there seemed to be a sense of frustration of what can you do, how should you be responding, and there was somewhat of a gap in communication. And to give you an example, Brisbane City Council sent out a text message on like Sunday night to say that the Brisbane River was going to probably breach its banks, but if you'd looked out your window any time before that, you probably could have reasonably determined that was the case. So there was this real sense of frustration at the time. And that led to widespread criticism. And a lot of that criticism was pointed at places like the Bureau of Meteorology. And the Bureau, they produce the weather forecasts, but how we translate the weather into impacts for our individual communities, how we translate it to a street level or a postcode level on a ground level, that's a bit of a challenge, right? And that's not BOM's job, but they copped a lot of flack for it. And one of the nicest things about the Queensland floods is that people wanted to help, and people like us wanted to help. And I'm going to talk a bit more about it today. But before I go too much further, let's talk about that sense of frustration and that sense of criticism people had. And it wasn't completely unreasonable, right? You're going to see this map a few times today as part of the group, because it was really part of the catalyst for what made me angry enough to organize the hackathon. So in the communication that people had when we were talking to people in positions of power or positions of government authorities, or we were talking about how BOM's forecasts were translated to people about the impact, there was a whole bunch of things that were missing in that discussion. And some of that was, where do you get your information from? So we had learnings out of the bushfires that we need a central hub of information, a central hub of data. And for us, a lot of the information was scattered across lots of different resources, from BOM to Transport and Main Roads to Queensland Police to Queensland Fire and Emergency Services. Where are we getting our information from? And I think there was a bit of a dereliction around what, in an academic sense, we would consider best practice principles around data visualization and how we even communicate and display data to people. When you look at some of the ways we had information available to us, when we look at maps like this, you can see that this is the prediction of the forecasted flood level for Brisbane City Council at its maximum extent. And there are things that are really missing there, like space and time and uncertainty. And there are other issues such as gaps in the observing practices. So we get one snapshot of the image, but lots of things were happening in all sorts of different places, and how that data is captured and used going forward is one of the things that I think we as a group hope to talk about today. So in my frustration with some of how we were communicating things, I wrote this conversation article with Kate Helmstedt, who was one of the co-organisers of the hackathon, and with my colleague Kieran Wan at the Dutch Bureau of Meteorology. And it was really about how we translate information about weather forecasts and what that means into information about risk for a given community or impact in a given community. And we talked about what was lacking and a bit of solutions when you look at other meteorological agencies. So for example, the Met Office in London, and how do they contribute? How do they issue their weather forecast warnings? But also we highlighted there was this gap in impact. So it's great to write an article and it's great to be part of public commentary, and that's all really lovely. But at the end of the day, we're still sitting there as part of the Queensland community looking at data science and data analytics-based solutions that actually weren't up to par. There were things that we in this room with our coding skills can look at it and go, oh, we could do that better. Like, I want to do that better. And with that in mind, we organized a rapid response hackathon. And that was with myself and Kate Helmstedt, who's on Zoom today. Hello, Kate. And this whole idea of a rapid response hackathon was just to put a call out to people. So I remember, I'm old enough to remember the 2011 floods. And I can remember cleaning out people's houses with a broom and like helping pick up photos and cleaning photos for people and doing other things. And I was like thinking about, oh, well, that's going to be me again. Like, I'm going to get out there and I'm going to help. And then I realized that actually had all this frustration about what was happening in terms of this data science based communication. I was like, well, actually, I've got skills now that are really useful to this public commentary, and I can be a difference in another way. Like, yes, I can go and get a broom, but turns out all these years spent getting an education and hacking away at code on R, well, actually, I can do some other stuff with that. And I wanted to be a part of a solution. So we put a call out, and we had lots of different people put their hands up and wanted to be a part, which was really awesome. And they came from all sorts of different coding abilities. We had a mix of novice R coders to more experienced R coders. Some people came from slightly different coding backgrounds, and that's totally fine because we're all trying to find a solution. So guess what? Spoiler alert, some of the solutions today are not all in R. We used all of our skills that are data science and data analytics based. So sorry if you feel tricked, but there are some of the post solutions are in R too. And basically, because we had this mix of all different people from all different places, you're just mucking in any way you can to help. So some people were really experienced web scrapers and great with writing really complex chunks of code. And other people, they were just mucking in and downloading data from the web manually. And you know what? That's really important. Because one of the reasons that we did this as a rapid response event is actually data disappears. So when the event happens, everybody's very focused on it. And now it's only been a few months later and we're like, oh yeah, that happened, right? That was earlier this year. And you start to forget a bit. So you don't capture some of the things that you need to capture and what happens on those websites around what the predictions were. Those things disappear. So you lose your data to validate. And that information, it might be captured in some government authority, but it's hard to get that later through formal channels or just hunting around. It's tricky. So you want to capture what's happening in that moment as soon as it happens and get as much data as you can that allows you to think about these things. And your understanding or your remembering of the things that impacted you during the event, how it impacted people, that you start to forget that there's amnesia too. So it had to happen quickly. Yeah. So as I said, I can muck out with a broom, but it turns out that I have other skills that are slightly better placed now to help be a part of this conversation that as Queenslanders we should be having. And so we organized a hackathon and there was a digital mud army, and here are some of the beautiful people's faces. I took a screenshot of you all while you weren't watching. I didn't ask for anybody's permission, and here it is, so you're welcome. And the 5 teams got together over this 2 days, very short notice, and we couldn't be at uni, right? We couldn't come to uni in person because of the floods. Public transport was out and we weren't allowed here for a start, and there was COVID. So this had to be an online event, which makes it different to most normal hackathons where you get in a room, you think about your problems together, you can be coding at the same time, and that made it a bit more challenging, but that's okay. We're all good at doing stuff in hybrid and online now, so that's all right. And the first half of the day, for the first half of the first day for us as part of the hackathon was just this brainstorming, was this getting everybody in the room and using their collective wisdom as people who were experiencing this event together to think about, well, what do we want to work on? Where were the gaps? What do we want to help with? So we had this big exhaustive list of different projects that people thought about, and these were the 5 that came up. There's visualizing the flood extent or the real-time flood extent. There was scraping social media data. There was road closures. There was visualizing past observations. and they was looking at this individual vulnerability within our communities. So I don't want to steal the thunder from all of our fabulous team members who are here today sharing their work. So what I might do is I'll wrap it up now and I'll pass over to our first team member. The way we're going to run it today is like roughly 8 to 10 minute presentations, and then you get to ask questions, and at the end we'll bring it all back together and hopefully have a bigger conversation around data science and data analytics and how R can be used. And you can feel free to quiz panelists as they come up. All right, so I will now introduce Charlotte.
Awesome. All right. Hi, everyone. Hello, I'm Charlotte. I'm representing my team of all of these great people, and we were looking at ways that we could better visualize real-time flood extent to give more detailed information for people on the ground. So yes, we were motivated mostly by this map. So this was the main information that was given out by the Mayor of Brisbane, and it was put on Twitter. And it was basically his way of saying, this is the predicted maximum extent based on high tide. So it was based on some flood models. And this is where you need to check if you're going to be underwater, and you need to make actions based on that. And then we realized very quickly that this was really inadequate for actually giving information at a level that you could tell what was happening at your own home, or if you were trying to get somewhere. So we were really interested in the ways that this might be improved upon. And this was also recognized as a bit of a shortcoming by people on Twitter. Yeah, so there was quite a lot of commentary just from people in the public as well. So yeah, lots of people realized that it wasn't really adequate, even though it was updated over time. So there was a few different predictions that were put out. The other thing that they directed people toward, this is an example where they're actually potentially using this map and printing it out for decision making. So I thought this was quite an interesting image. Maybe it was just staged a bit, but you know, it doesn't seem like an adequate piece of information that you could use to make decisions. There was also this resource which was pointed to. This was a flood awareness map. So it's based on predictions that were done in 2013. And it gives some indication of the likelihood of different areas being flooded over time. This was a static prediction, so it basically is assuming that the climate isn't really changing over time. It does allow you to actually go in and locate somewhere like QUT and click and find out which likelihood you're within. So whether you're in the sort of every year you've got a 5% annual chance of being in these flood events. So that gives us a little bit more information, but if you're actually in a flood, you're probably not going to rely on this, because floods are very dynamic and they change depending on a lot of other factors. So yeah, that was the sort of rationale. We wanted to see if we could do a better job. So we were thinking about ways that you might be able to use the real-time information that comes from the river and use that in a way to create something that's useful, interactive, and can be allowed to incorporate some uncertainty in predictions as well. So our solution that we're proposing is just more of a discussion. So quite a bit of our time was just looking at sources of data and trying to find out where we could get information from. And we have some of the prototypes of what you might be able to do as well. So our concept was that you could create a hub that was online that had real-time flood extent data, which was based on river height information, and then also maybe use some of the predictions that were presented in the previous slides to show some of the potential flood extents over time as well. So we found that there was river height data that was available from BOM, and there was a 25-meter digital elevation model, which could be useful. There was also previous predictions and flood extents from previous events that were based on satellite imagery. So we sort of had to play around with all of these data sources. Okay, go a bit louder. Yeah. So this is the river height data that we found. So this wasn't downloadable. We had Jackson from another team who scraped the information for us. And basically for each river gauge, there was information about the water level over time. So we took this information and then we realized we didn't have any idea, apart from the description, where these gauges actually were, and there wasn't easy information about that. But Raiha, who was in the team, managed to find the location. So we did some of the R coding, which I'm not going to show you because it was just data cleaning, and we combined the information of the river heights and also the location of the river gauges. Just going back to that for a second, so just the theory of what we could do, which we didn't do, was you could take it as a very simplistic representation of what's happening, but you could take the height of the river gauge itself and then the height of the reading that it has, and look at across an area what land is under that height. So you could also do some more sophisticated modeling like the ones that they did to make this map. So here we were thinking about ways that you could just better visualize this prediction. So we thought we'll take the shape file from this, which wasn't available. It's just a PDF file. So Matthew and the team geo-referenced and rasterized this for us. And then we were thinking that it would be great to explore ways to incorporate uncertainty of predictions. So that's something that was missing from the maps that were shown. So we could look at ways to incorporate shading or looking at different pixelation sizes, just to show, if you're doing predictions, where are we really certain that floods are actually going to happen, and where are we very not certain, but we're going to present this anyway, and doing it in a way that people can actually understand as well. So that was Owen's contribution in thinking about that. So our final prototype that we made was written in Java by Miguel, and it was just a web-based interactive map that would allow you to present different information and different predictions, but in a way that is accessible, and you can zoom in really closely on where you live and just have a better representation of what's going on. So the blue is just the layers from the flood awareness map that I showed at the beginning. And then the red is just an example where you could present the extent from a previous flood event. So Larissa here actually took the flood event that we're talking about, the February event, but you could present previous flood extents. This is just a rough indication of what might happen in the future. And this we didn't add this part into the prototype, but this is just an example. If you had a river gauge and you used the digital elevation model to look at where is below that height of the water level. So you could use the uncertainty of the shading to visualize where we're pretty sure that that this is going to be flooded and where it might not be, but it could be. And you could incorporate a 3D map, which might allow people to get a bit of a better understanding of the landscape. I think sometimes it's a lot easier to visualize stuff when you have a 3D representation of what's actually going on in your neighborhood. Yeah, so to sum up, we just explored some ideas for ways that we could use real-time information. And the take-home message was, if you've done the effort to make flood predictions, then present them in a way that is accessible and you can easily interpret, and you can interact and actually get the most information that you need out of it at a good resolution. So yeah, thanks to my team members. And yeah, happy to take any questions now or later.
Right, well, good evening, everyone. I was part of the road closures team. My name's Peter Tubbett, I should say. And this is our lovely team. We had Sarah Volliot, Kaylee Jen Smith, and Jackson Kwok. All right, let's talk about motivation. Back in February, once the floodwaters started to recede, I took my bicycle and rode out to survey for myself what was going on, curious and all. And this is a photo I took on that trip. And I ended up being very glad I rode my bicycle, because the traffic around South Brisbane and West End was absolutely horrific. Many of the roads and streets were still cut off, and a lot of confusion and frustration. A lot of motorists seemed to be very unsure of not only just how to get to where they wanted to go, but to find any way kind of out of South Brisbane. And this was after the flood while the water was going down. So you can only imagine what it was like during the crisis for people frantic to get home, emergency workers trying to respond to situations. So it's a big problem. Looking at the current data we have to solve this problem, Queensland Traffic has a list. Can I scroll here? I can. They have this list view of all alerts on all their roads. It's very good, very detailed, but it's not in a very helpful format for people who just want to know, can I get home? Like have to manually search in every single street and road on their trip and see if it was affected. So that's not very practical at all. They do have a better version of this data displayed as a map. And it has pins to show all this data. You can click on the pins to get that same information you had last time. And this is a great visualization during regular times. But during the crisis, it was overwhelmed. Just the amount of problems caused the map to be very cluttered. And they were struggling to report every single incident in a timely manner or at all. So it was not a complete picture of what was going on. As has been mentioned previously, there was this visualization by the council. You could, I guess, try and look at the roads and see if maybe they were affected, but it was just a prediction and it's pretty hard to read. And as well as that, there's services such as Google Maps and the like that have traffic data. You could try and look at this and guess at where disruptions lie, but that is just guessing, and that's not very practical for a crisis. So what was our solution to this problem? Well, initially we were looking at web scraping, the Queensland Traffic list page, and then using that same data to make a better map visualization. But we had a few problems with this. It's quite difficult to do just because of the nature of the web page. And even if we did manage to do it, it still didn't solve the big problem of incomplete reporting during a crisis. So to solve that problem, we looked at crowdsourced data to fill this gap. And that left us with two questions. How do we get this data? And how do we display that data? And we solved them by using the R packages Shiny and Leaflet. So R Shiny allows you to launch an R project as a web app, which is great for getting your information out there and also allowing users to interact with it. And Leaflet is a R package which allows you to process and plot map data, which is very helpful for us. And it already has built-in functions to work well with Shiny and handle all those interactive functions. The only missing piece then is our mapping data. And for that, we used OpenStreetMaps, or OSM for short, which is a collaborative project to create a free editable geographic database of the world. And it's very good. It allows us to do things like this without paywall subscriptions and all that. I didn't have much of an idea of using OSM data in this kind of way before the hackathon, but our lovely group member Jackson did a great job of teaching us, so big shout out to him. Map and spatial data can be very intimidating, but I'll do my best to keep kind of a quick rundown on it. So from the OSM website, you can download map areas. And so for this project, we downloaded the Brisbane file. It comes in a PBF file, which is similar to an XML, and it contains 5 layers. I'll just go over these quick. These names might seem like a lot, but they're quite intuitive if you think of them as what they would be on a map. So points are like points of interest, shops, stations, restaurants, anything that'd be a point on a map. Lines are anything that'd be a line on a map. So ways, paths, streets, roads. M lines are routes, and M polygons are anything that would be a polygon on a map. So buildings, reasons, suburbs, anything like that. And I was going to go through some code, but I don't want to take all day. So we might just jump into a showcase of the app, hopefully, if the technology will work for us. Otherwise, I'll just have to describe it for you. Oh, here it comes. So here it is. Can I zoom? Yes. Excellent. So as you see, we have a map of South Brisbane. with all the roads and major paths highlighted. There is a search box here, so you can search for roads if you want them. Otherwise, if you hover over a road, you can see a number of how many people have reported it as closed. So at the moment, it's all 0, everything is open. But if, say, we were to click on a road, maybe this one here, we can highlight it, and my report road button is covered up, which is unfortunate. There we go. You can then flag that road as closed, and it turns red, and hopefully that now reports one road closure. So this is just a simple proof of concept, but it allows people to report any incidents as they come across them, and that hopefully should allow anyone else before they arrive at the scene to know what is going on. That's pretty much it. There's obviously a lot of things we can do to improve this app to make it a full product, tidy up the aesthetics for a start. At the moment, it's just doing South Brisbane because to have your own free shiny app, it has to be quite small, but for a full project, it could quite easily show all of Brisbane. At the moment, you see it kind of goes full to red as soon as we have one person report it. In the full version, you'd want maybe a color scale, so it just slowly changed from blue to red as more and more people reported the road was closed, and we'd have to be more and more certain that it actually is. Also need to be able to save these reports to a database. At the moment, it just disappears as soon as the app closes. And we'd have to have some way of the reports decaying, or someone being able to say the road is open once it is open again. One last thing that'd be very nice to add is the flood mapping data from the previous, such as the stuff from the previous team's entry, to be able to add that to this map as a layer. So people could see maybe live flood data or an estimate of the live flood data, and maybe even be able to automatically flag roads that are being touched by that flood extent data. All right, that's all I have time for. So, any questions? Yes. Yes.
So I guess could you link it with that road closures website?
I guess so. I guess they could like build this kind of functionality into them. This is just kind of a proof of concept of the idea at the moment. Yeah. Yeah. One thing we did look at is since we were looking at scraping that data, maybe we were still looking at that, maybe being able to plug that into this app, but we ran out of time to really do that.
Yeah, no, lots of dream,
Yeah.
things, but that's really great, amazing work. Everyone, lots of comments in the chat for you about, Kate says the crosses look like dead people, but anyway, thanks, Peter. Thanks so much.
Okay. Hi, my name is Tace and this is Lancy Lee. And we are part of the social media scraping team. And what we did was a citizen-based disaster warning system. The motivation behind this, Kate has already mentioned this article, but the problem was that people could have prepared for the floods better if the impacts of the weather forecast were clearly communicated. And as a little side note, I remember when going through the floods, we had an announcement from the Queensland Premier saying that it wasn't going to be like the 2011 floods. And in some places it wasn't like the 2011 floods, but in some places it was much, much worse. And they really needed to be warned of that, specific to their area. You've already seen this PDF, but the gap here is that national governments and state governments and even city councils, they cannot realistically provide detailed, dynamic, street level warning information that is helpful enough for people to know when to leave or not. As an example, this Brisbane City Council provided this PDF, and if you zoom in as far as you can on Brisbane City, most of the land area is covered in text for the suburb names. And if your area of interest is underneath that text, good luck to you for finding out whether you're going to be flooded or not. So our solution that we proposed was a citizen-based warning system. And what that means is this warning system scans social media for posts about a disaster, and anyone can access this system. And what they see is a map of their location, and all of the posts that this system scraped from the internet are identified by a pin on the map. And so you can click on a pin and you can see what was posted and the photo that was with the post. An idea here, I actually wanted to get rid of this point, but I kept it in. One of the ideas was to have an option to vote on the danger present, but we didn't do this, so I'm going to skip past it. So we made a prototype for this warning system. So you can see the map here, and these little red dots are the pins for the posts that were taken from Twitter. And on the left-hand side are photos of each post. And unfortunately, we weren't able to actually get the photos onto the prototype, but that was the main idea, and that would be a fix for the future. And so if you click on one of those posts, then you get to see the username of the account that posted, their general location, the text that accompanied that post, a link to see it if you wanted to see the comments or comment on it yourself. And of course, the image and the time that it was posted. And to find this, to get this prototype up, we started with data of Twitter posts that included the words Brisbane and flood, but of course, we would expand it to all suburb names and perhaps even all disasters. And they had to include a photo and were posted between the 28th of February and the 1st of March. And of course, these can easily be changed. So we experimented with lots of different date ranges, and you might see some different dates here as well. I'll now pass on to Lancy, who will talk about the code and the outputs.
Yep. So this is the main part of the code. And we firstly used the package tweetp to scrape all Twitter data from, but we found it's only gave us the post is from the most recent 7 days. And at the time, we've already lost the first day also of the floods. Then we started to use the other package, which is SN scrape, which is able to give us all tweets in specific big day range. And the query we used were the words Brisbane and flood, and filtered by photo. Okay. So,
Just say where you're going.
yep, the output is following here. So the first output, we haven't showing in this slide, but the first output is a table where the row entries are posts and the detail column are included date, time, ID, tweet ID, that text, username, and media. The media column includes name or photo or video. We of course can get the photo from the video. And the other output is a folder which includes all photos fitting with the query. So here are two good examples of our photos that we already collected. We think this could be helpful to a resident or tourist who wants to know if they should take their essentials and leave the areas without traveling to the flood water area themselves. And but of course, there are some photos are not as useful for someone who wants to know if the severity of the situation. The future work would include filtering the posts and photos to be clever about what is helpful to the community. So we start our project small and focused to the Twitter as our social media and Brisbane as the search location. But future additions would include fixing the front end, expanding to multiple social media platforms and other disasters such as cyclone and bushfires, expanding to all suburbs in Australia, expanding the day range. And of course, the last point, it's not our latest version, but the last point is about we want encourage people to take photos and record local impacts. Okay, that's it. Thank you for watching. And if you want to see more, our code is available on GitHub.
I'll just repeat to everyone on the internet. So Kate Saunders asked if how we would separate the images into the desired and the not desired. So how can we filter those images? Do you have an answer yourself?
Yes.
Yeah.
So it's more difficult in just coding because we need to use the CNN, the Central Neural Network, to classify the images, and then they would have some algorithms for classifying flooding and non-flooding images.
So for the internet, the question was, how would we store, or how would we deal with data storage when we're dealing with many, many photos and posts? I don't have an answer for that.
So for the data that we collected from the social media, so my research is about this area, so that the data that I collect will stored on cloud, and that it's got the permission from QT, and but we don't share because it's from the public, and then but we don't share this to other people because it's about the human ethics problem. So we only share my code, but not the data. But we will have the data backup on QT Cloud.
Angela says, awesome ideas. Should pitch these to the prototypes to the disaster response teams at local governments. Yes, totally agree. And Kate's saying we're gonna write them into a publication tying up all the proposed solutions.
Okay, great. Good evening, everyone, and I'm sorry for not joining you in person this evening. I'm going to talk about the work of the Past Observations Group, which consisted of myself, Oakes Holland, soon to be Dr. Oakes Holland, and Dr. Kate Saunders. Our focal question for this group was, how did the rainfall preceding the 2022 floods differ from the rainfall preceding the 2011 floods? The data we used to investigate this question were rainfall time series data from the Bureau of Meteorology weather stations, accessed through the Global Historical Climatology Network daily dataset, and drainage basin boundaries, accessed as spatial polygons from the Queensland Government Spatial Catalogue. So I'm going to jump straight in and show you a visualization of these data. This is the first major visualization we produced of these data. So you can see it's an animation. We have the points themselves are weather station locations, and we're moving through time, looking at daily precipitation totals. And we have on the left, we have data from 2011, and on the right, we have data from 2022. And the time sequence we're moving through is, I think it was from 90 days prior to the maximum high water level of each event. And so as the animation progresses, it's moving towards that date of the highest water level in 1 day steps. So this gives you an idea of what the data look like, but the user would have to do quite a lot of mental work to really extract differences and make meaningful comparisons from this animation. It's interesting to look at, but you'd have to remember quite a lot to make a good comparison out of this. So I'll switch back to my slides again. Where we got to was this visualization here. So what we're looking at here are each of these panels in the figure is a map of Southeast Queensland. Hopefully you can see my cursor. If not, the edge on the eastern side is the coastline. Hopefully you can recognize the islands and the coastline of Southeast Queensland. And then the polygons themselves are the boundaries of drainage basins. So you can probably see the Brisbane catchment in there as well. And what we've colored these polygons by is the catchment level mean of the total precipitation at weather stations over different time periods leading up to the highest water levels in the 2 different years. So we have the 2022 data on the top row of the panel and the 2011 data on the bottom row. So in these, in the columns of this image, the precipitation color scale is the same. So you'll see if you look at the top row and the bottom row of any particular column, the color scale is the same. So you can compare them in that way. And with a visualization like this, we can much more easily make comparisons. So we can see that in the 3 days leading up to the maximum high water level in 2022, a lot more rain fell than did in the 3 days leading up to the maximum high water level in 2021. And this was largely consistent across the different catchments that we're looking at here. But then if we look to the right in this image, and we start looking over larger periods of time, including the date of the highest water level, we can see that there was a lot more rainfall over the preceding summer prior to the 2011 event than there was prior to the 2022 event. So we can extract from this the information that the 2022 event happened really quickly. There was a major rain event, and that caused the flooding over a few days, whereas the 2011 event is the result of this build-up over literally months. So because this is an R meeting, I'm going to talk briefly about producing that second figure. So we downloaded the global weather station metadata using a package called RNOAA. Then we identified the stations of interest by spatially intersecting them with the outlines of the drainage basins. This was done using SF and the tidyverse. This then allowed us to identify which weather stations from that global data set we were interested in, and just to request the weather data for those stations from the server providing these data. We then tidy those data into a simple features object, which, if you've not heard of them before, is a tibble with geometry elements in a list column. Then we were able to summarize the rainfall data and it had been grouped by drainage basin and time interval, and then join those summary statistics to the drainage basin boundary polygons, and then we could plot the polygons mapping the summary statistics to the fill color. And that's how we produce these polygons with different fill colors representing catchment level mean of total precipitation at the weather stations over these different time periods. So there's a quick list of the R packages used. I'll conclude by saying we built all of this off code that Dr. Kate Saunders had already written to work with the GHCND data. So we had a really good starting point there. So you can, I provided a link to that if you'd like to have a look at it. And what we did in the hackathon was really, once we'd got the data, it was a sort of a question of organizing it and then producing these visualizations. So you can see our work on that at the link below. Thank you very much.
Kate's got a question in the room here. Yep.
Have you thought about going even further back then?
Have you thought about going even further back than, I guess, more than 90 days before the event? Yeah,
1974 flood. So we didn't go
Oh,
back.
okay.
Looking at it now, we're obviously interested in 1974 and the evolution of that event. as well.
Okay, so that was actually looking at more historic floods like 2011, 2022, 2011, and 1974, and comparing like, was it a seasonal buildup, kind of like 2011, or was it more of a, was 74 because of a cyclone? Was that right? Okay, so
Bit of everything.
yeah. Have you looked at 74 at all by any chance, or any thoughts about that?
So I haven't, but I can tell you that it's in the data. The data we're getting back, I think, back to the early 1900s from memory. So what I'm showing you is the result of a couple of days of hacking. So we just did a pairwise comparison, but we could definitely pull out some other intervals.
Right, so any flood event after 1900 something is like 1910 would be fair game. So Kate's smiling.
I believe. Hopefully I've got the start date right. I'm going from my memory of the data set, but I think it went back quite a way.
That's like a hard hint from Kate here to
Yeah.
look at them all, maybe. Someone also is mentioning, also look at La Nina events, maybe, you know, correlations with that, with the historical flood events as well. Yeah, so all the code is there. So I guess it's available for everyone to just, yeah, have a go, I guess.
Absolutely. Have fun.
Thanks so much, Ben. Okay, so now it's my presentation. I'm going to just share my screen. So this is like the first time I've done our markdown slides. Like the first slide didn't work. Anyway, the important information is the team people, my team members here. So I'm Catherine, I'm a postdoc here at QT. And then we've got Caitlin, who's here, Richard, Jess, Aiden, and Connie who are on my team. And we were looking at a vulnerability index for the Brisbane floods, which was on the main slide. Anyway, but yep, so some motivation. So we were specifically kind of reflecting on our flood experience. And so the main, you know, impact is you are flooded or not. And that obviously has a lot of implications for, you know, for the impact, right? But then and so like thousands of people were flooded, homes, properties, shops, etc. But also there were a lot of impacts beyond, you know, being inundated. And so that was like access to services. So we heard Peter talk about road closures. And so that was a whole, you know, big mess. Also things like shops, hospitals, you know, petrol stations, also the loss of power. So if you're flooded, of course, your power is off, but also if you were close enough to a flooded area where that particular, however the power grid works, that substation was flooded. And so some, you know, certain area connected to that substation is also out of power. You know, some people who weren't flooded didn't have power for like a week or so. And then yes, public transportation closures, as Peter mentioned. And so the gap, we've all seen this map, wasn't super helpful. I'm going to just skip over it because lots of people have touched on that. And so our group was trying to think about this as a vulnerability index. And so what is vulnerability? There's this equation of vulnerability from an IPCC climate change report back in 2001. So it's not a new concept, but this formula is composed of exposure, which is the immediate effect. So in flooding, it'd be like, are you flooded or not? Sensitivity, which represents the longstanding innate properties of the population, and then adaptive capacity, which are, you know, things that can be done to change the impact. So kind of like resilience. And so our approach was to create a vulnerability index for Brisbane City local government area, or LGA, and try and predict the vulnerability at each level 2 statistical area, which is like Australian census statistical zones. Right, so specifically for our this scenario, we were looking at exposure as like flood extent intersecting with, property, services, infrastructure, and even going beyond maybe like flooded or not to include rules for certain services like power. Like, so if a substation is flooded, then maybe, we do a buffer of X, meters or something. We have to find out what a appropriate number would be. And including that as maybe like a, weighting it maybe slightly less than being flooded or something. Obviously, the various levels of exposure with being flooded. If you're a few centimeters flooded versus, a whole first story is flooded, those are two different things. And then also trying to measure changed access. So if, you're not flooded, but the nearest shop you usually go to is flooded, then you have to go to the nearest unflooded shop. And then in addition, there might be road closures and other barriers that might, make that a whole much harder than just simply going to the nearest unflooded shop. And so exposure is probably the most straightforward component. And so then sensitivity is looking at demographic data, socioeconomic data, et cetera, and kind of getting, kind of averaging them across the SA2, the statistical areas. And so something like a SA2 that has a higher proportion of, has an older population might be more sensitive, or like a SA2 with a lower socioeconomic like income, for example, also might be more sensitive. So kind of using that to weight the sensitivity. And then the last one, which is probably the trickiest, is adaptive capacity, which is actions in place to, increase resilience to flooding. And so there's some examples like, buyback programs. Like I think after 2011, they did, council did buyback properties in certain areas like Rockley sort of area that were, very flood prone. They have, Queensland has moved whole towns. Like there's this example of Grantham. But probably the most like applicable to this situation is probably something like minimum build heights. And then even we talked about like with shops. So, you have two shops that were flooded, but one is designed to be more resilient in that maybe the first floor is only parking, and like the generators and all of that critical infrastructure is not on the first floor, it's on the second floor. And so in an event where, one that is designed to be resilient is flooded versus one that's not, like during the event, of course, both are not accessible, safe to access, not available. But then maybe the one that is designed to be more resilient, it just takes a matter of, a day of cleaning and checking everything, and then it's open again, and then people can, use that service versus, being closed for, a week or something. Yeah, so those are just some examples. And then just really quickly, so I'm mostly going to cover kind of the exposure bit because that's the easy part. And so we use, similar to what Ben said, we used SF for the spatial data, tidyverse for data manipulation, and also OzMaps is a handy package for mapping in Australia. So all the code I'm going to show is from Rich. And then like other teams have mentioned, QSpatial is a really great resource. And then Kate was really good at finding, like, oh, do we have, I don't know, bus stops, and then she would be like, bam, she found it. So yeah, a lot of finding data. And so this is just an example of like a flood extent plot. And so read it in and then plot it with the geom, SF function there. So, and we haven't really decided about whether we're going to use, which flood extent. I think this is a general model, so it's not particular to any specific flood. But we take that, and then we take our LGAs and our SA2s. And then if you plot those, so this is the LGA. So this is the area that we're focusing on just to keep it a bit manageable for the time being. And there are some differences, of course. So like the LGA includes Moreton Island, and then it's not included in SA2s. And I think this is Redland Bay, which is not actually in Brisbane City LGA. So some, data cleaning associated with those sorts of things. Also, just really briefly looking at emergency services, we have, so there's ambulance services are the red dots, green dots are the fire and emergency services. And then we have police stations. So we can see there's, a smattering around in Brisbane City. And then with petrol stations, again, some reading it in, data manipulation, and then kind of putting it all together These aren't all the variables that we're trying to consider with exposure, but kind of a summary. So then obviously we have, some services that are inundated, but then, trying to do things like maybe calculating the average distance from an SA2 to the nearest shopping center. And that might change if, one shopping center is flooded, those sorts of things as well. And so we're very much in a work in progress state, and we spend a lot of time trying, what goes into each category. And then obviously we have to turn this into an index. And like, what does that mean? We have to combine all the variables for each component, like all the exposure ones I mentioned, and, somehow weight them and score them into one sort of metric. And then we have to add, our exposure, our sensitivity, adaptive capacity, and then decide what sort of scale we want our vulnerability index to be. Is it going to be 0 is, least vulnerable, and then 1 is maximum vulnerability, those sorts of things. So if anyone has any ideas, that'd be great to hear. And so, yeah, our dream thing would be like have this amazing shiny app where you can toggle like your income of your SA2 and, your shop is resilient or not, have all these, things that you can change to see how maybe you could increase or decrease the vulnerability of your SA2, etc. That's just a GIF. And yeah, so that's all I have. And so this is our team. And yeah, thanks so much. Okay. Yeah, any question? Okay, well, any general questions? I know now I was the last one, so. Okay.
Yeah, any general thoughts or feelings that people would like to share? I think one of the things I really think is important to emphasize is that 2011, where we had all our really big learnings from flooding, I don't think data science was a word. I don't think data science was a profession. I don't think data analytics was a thing. Our tidyverse didn't exist. So that's kind of crazy when you think about it in the context of that. So all of these solutions and just how novel and impactful they are, I think that's not to be underestimated. And I just want to thank all of our wonderful speakers today for coming up with such creative ideas and solutions and being a part of a frontiering discussion around how we should be doing this for natural disasters and how we should be doing this for Queensland. So yeah, thank you, everybody.
Yes, does Kate have a comment? I think I see a hand.
Yeah, I just wanted to reiterate, because a lot of this stuff I hadn't seen since the days that we had the hackathon. And so it's just incredible to see how everyone's really kind of progressed their piece here and made this really neat and awesome thing. I think everyone spoke about it incredibly well. I think everyone's work is really cool. And I know this wasn't a lot of people's home discipline. It wasn't a lot of people's homework that they were doing as their core business. So just really incredible to see how this community has kind of rallied around this idea. Well done, guys.
Yeah, it's definitely worth emphasizing that a lot of these solutions were developed over the course of a day and a half, which is crazy good. So really well done. Okay, well, thank you,
Excellent.
everybody.
Well, thank you so much.
Thanks for today.
Round of applause.